Hi, good evening. In this seminar, we are going to talk about refrigeration and its types. In this seminar, we are going to see about introduction to refrigeration, their history, refrigeration principle, unit of refrigeration, methods of refrigeration, VCR cycle, VAR cycle, magnetic refrigeration, principle of magnetic refrigeration, thermodynamic cycle, components required, applications, advantages of magnetic refrigeration, disadvantages of magnetic refrigeration, conclusion, and finally reference. The first is introduction to refrigeration. Refrigeration is a process of removing heat from an enclosed space or from a substance. The primary purpose of the refrigeration is lowering the temperature of the enclosed space or substance and then maintaining that lower temperature. The next is unit of refrigeration. 1 ton of refrigeration is a rate of heat removed required to freeze a metric ton, that is 1000 kg of water at 0 degrees Celsius in 24 hours. It is expressed in tons of refrigeration or kilowatt. 1 ton refrigeration is equal to 200 BTU minute per minute, equal to 3.517 kg per second, equal to 3.517 kilowatt. Most residential air conditioning units range in capacity from about 1 to 5 tons of refrigeration. The next we will see the history of the refrigeration. The effect was discovered in pure iron in 1881 by U. Barbach. Originally, the cooling effect varied between 0.2 K per T. Major advance first appeared in the late 1920 when cooling via adiabatic demagnetization was independently proposed by two scientists, namely Debye and Jacob. The process was demonstrated a few years later when Giacca and McDowell in 1933 used it to reach a temperature of 0.25 Kelvin. Between 1983 and 1997, a number of advances was utilized for cooling occurred. This cooling technology was first demonstrated by chemist Nobel laureate William Gotch and his colleague Dr. P. McDowell in 1933 for cryogenic purposes. Between 1983 and 1997, a number of advances occurred, which have been described in some reviews. The next you will see a working principle of refrigeration. It works on the second law of thermodynamics. The first is classic statement. Heat cannot be spontaneously flow from cold regions to hot regions without external work being performed in system, which is evidently from ordinary experience of refrigeration. Kelvin statement, it stipulates the some portion of the energy absorbed as heat from the source must always be rejected to the lower temperature sink. The next will be methods of refrigeration. The methods are non-cyclic refrigeration, cyclic refrigeration, vapor cycle is converted again, vapor compression refrigeration, vapor absorption refrigeration, and finally gas cycle. The next is thermoelectric refrigeration and magnetic refrigeration. The first will see the vapor compression refrigeration. There are 4 processes in VCR cycle. Isentropic compression of saturated vapor in compressor, isobaric heat rejection condenser, isenpethalic expansion of saturated liquid in expansion device, isobaric heat extraction in the evaporator. The next we will see the vapor absorption cycle. The vapor absorption cycle using water ammonia systems was popularly and widely used. Ammonia is used as a refrigerant, water as the absorbent. Another pair is also used, which is water and lithium bromide. Its COP is about 1/3 of that of the vapor compression cycle. The next is magnetic refrigeration. Magnetic refrigeration is a cooling technology based on the magnetic calorie effect. The magnetocaloric effect is a magnetothermodynamic phenomenon in which a change in temperature of suitable material is caused by exposing the material to changing magnetic field. Further, in next PPT, we will see about the components and working principle of the magnetic refrigeration. Thank you.